Okay, so this first video we're going to take a look at composition of functions. If you take a look at number 1 here, we've got f of x equals x squared plus 2, g of x equals square root of x, and you're asked to do a composite, at least with b, c, and d. In this first row here, part A, this is just a multiplication problem. So f of x times g of x, you could just rewrite the x squared plus 2 right here for f of x. G of x, since it's square root of x, you could just call it x to the 1/2, and then it's just a matter of distribution. So x to the half times x squared. You remember to add your exponents up. So this is going to make 2 plus a half, so 2.5, or just 5/2. And then plus 2 times this, so that could just be written as 2 times the square root of x, or x to the half power, either way, but that's it for part A. So part B, so this is a composite, f of x. So the first thing to do is to start with this outer function f of x, which we have right here of x squared plus 2. And what you could always do is just leave the x as a parentheses right here, and then take whatever function you have inside and replace it where there used to be an x. So right here, you would just replace it with an x squared plus 2. There's really no need to FOIL that out. You don't have to. You could just leave it like that for full credit. A different problem on part C, you got g on the outer function. So if you just start with the square root of x, or square root of a blank right here, then the f of x goes inside g. So the f of x part, the x squared plus 2, just goes here. And remember, this does not simplify. You can't, because of the addition, you can't simplify this to just like an x and a square root of 2. Like this would be incorrect. You do not want to do that. So that is wrong. You just leave it just like that. Alright, this last example here, you've got f of g of x. So f is on the outside. So if we start with the x squared plus 2, or just blank squared plus 2, the g of x is inside f, so we're going to take the g of x function, the square root of x, and put it right here. This, since we're not adding right here, we could just simplify square root of x and squared to simply equals x plus 2, and that would be it for how to do the first problem. Alright, now let's take a look at problem number 3. So again, this is another composite problem. So if we take a look at this first one, it's just finding out what f of 3 is. So remember, the 3 just gets replaced to this x and this x. So this will be easy enough. Just don't mess up the order of operations part right here. 3 squared is 9. Do that first. Times the 2 is 18. 12 plus 18 is 30. And then that's no problem. But when you see something like this, I've seen some confusion with some students here. This whole piece, this x plus h, all goes into these x's here and here. So to set this up is just 4, and the parentheses, you're just going to replace this x with an x plus h. And this x over here gets replaced with an x plus h. So to simplify this all out, you distribute the 4x plus 4h plus, you have to FOIL this out or distribute this all out right here. So that's x squared plus 2xh plus h squared. But then you're going to have to take this 2 and distribute it to all of that. So this is going to end up having a 2x squared plus 4xh plus 2 h squared, and then you have this part here, a 4x plus a 4h plus, and then you're going to look for anything that you could add together, and if you look closely, there's nothing that has like terms. So for part B, you are all set. Alright, so now let's take a look at part C. So what we've got here is f of x plus h, which you've done right here in part B, minus f of x. So all of this here is what you got from part B. This is minus, so don't forget to put parentheses around f of x right here, because what you have to remember is to distribute through this minus sign. So what's going to happen is you are going to have a 4x here and a minus 4x here, which are going to cancel those out. You're going to have a minus 2x squared and this plus 2x squared right here. So what you're going to end up with is a 4h, a 4xh. You're going to have a plus 2h squared, and that's all divided by h. So you can't cancel out an h with an h yet until you make the top a multiplication problem. So let's equal this. You're going to factor out an h here. So you're going to be left with a 4 plus a 4x plus a 2h, like that. Now that you have this as h times something, now you can take this h here and cancel it with this h here. And your final answer to this problem is 4 plus 4x plus 2h. Anytime you see one of these problems, you're always going to be able to factor out an h on the top to be able to cancel it with the h on the bottom. So every single time, that's how those are going to work. Alright, now let's take a look at problem number 5. Do a couple of those examples here. So if you have this graph given, you've got g is this function here, f is this linear function here. 5a would be easy enough, g of 1. Let's just go to 1 for x, the y-coordinate is 0, so that would be it, g of 1 is 0. So for b though, you've got f of g of 1, so since you already solved g of 1 is 0, now the problem becomes f of 0. So you go to 0 for x, and then you go up to the f of x function. You've got that as a 1. So that's your answer right here. So for part D, you've got g of negative 3 on the inside. So you go to negative 3 for x. 1, 2, 3 right here. Go up to g, that's 4. And this just becomes f of 4. So you go to 4 for x. You go up to the f graph. The y-coordinate is 5. And that's it. So that's how these all work. Let's take a look at number 7. There should be a little parentheses right there. So you got f of g of x minus 6, and that's defined as h of x. So you're making your x a 1 for part A. So it's essentially just asking you to go f of g of 1 minus 6. Well, you look for the x to be a 1 right here. And g of 1 is 2, so this problem becomes f of 2 minus 6. Now x is 2 right here, so f of 2 is 9. So that's a 9 minus 6, so your answer is 3. So h of 1 equals 3. And that's how these work.